Okay. Pascal's triangle. How do you get Pascal's triangle, people? You don't know how to describe it. Start with a 1. What's the next row?
1, 1.
1, 1. What's the next row?
1, 2, 1.
How do you get the middle number?
You add the 2 above it.
There we go. So the next row, it's always 1s on the outside. What's the number after this? 2 and 1 is?
4. 2 and 1 is 3.
Thank you, Will. 2 and 1 is?
3.
And then 1. Next row? 1. Add 3 and 1, you get 4. Whoa, what is going on here? 3 and 3 is 6. 3 and 1 is 4. And then a 1 on the outside. And you just continue that all the way down. All right. So, and we use this to expand binomials. We're not going to do that right now. But what we can also use it for is to figure out the number of routes or paths going from A to B of these grid patterns. We always have to move closer to A. So we did this before, is we have to make 1, 2, 3 moves across. So three blocks right. And then 2 moves down, no matter which way we go. 2 blocks down. So if we thought of them as R, 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 and 2 Ds for going down, how many ways can you arrange those? Peoples? People who are actually in Math 12, or we're not in Math 12, Calculus 12. How many ways can I arrange these letters? R, 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 D, D.
5 factorial.
Thank you. Because you have
5
4 choices, 4, 3, 2, 1.
And is this a combination?
No, it's permutation.
Permutation
Because the order matters, right?
Because I thought since there's like multiples of R's and multiple D's, does that count as like a repetition?
Yes. So it's 5 factorial divided by? Yeah, divided by 3 factorial, 2 factorial. So there's 10 ways to go from A to B. Okay? You can do that by using Pascal's triangle as well. So what we can do is we can overlay Pascal's triangle on this grid. Green. That's going to be the top of the triangle, 1. All the way down the sides at each intersection is a 1. And then 1 and 1. And you stop at the corners. Then, to get the middle, to get this number here, I add the 2 that are attached to it. So that's going to be 2. This one here, I'm adding the 2 that are attached. So 2 plus 1 is 3. This one here, 1 and 2 is 3. The next one, 1 and 3 is 4. What number is going to be here? 3 and 3 is 6. And the final is B. How many ways can you get from A to B? 10 ways, same as this one.
So the number on Pascal's triangle is the number of ways you're able to do that.
Yeah, whatever that number is at the bottom of at our answer. Because Pascal's triangle actually, we just don't see it, but it's extending out, and then we're just missing all the numbers in between, right?
No, I'm saying anywhere on the triangle. That
Yeah.
number, anywhere, any number is the number of ways you can get
From,
that number.
yes,
Going down,
and to the, or,
to the down right or down left.
yeah. All right. Okay, so that's a simple one. We're gonna, can I flip the page?
Yes.
No, it's not that bad. So, we're going to go from A to B of the first one. If they're at a corner like this, split them into 2 separate ones and multiply the answer. So, if it's a perfect rectangle, square, without any weird shapes in it, the easiest formula is going to be total moves factorial divided by your repeats. It is. You have to yell it. Okay? So, how many movements do you need to make to get from here to this bit right here? 1, 2, 3, 4, 5, 6, 7 total. And then you look at the repeats. How many moves right do I have to make? 3. How many moves down do I have to make? So you divide by 3 factorial, 4 factorial. And then treat, sorry? 3 and 4. 7. Oh, hang on. Then you got to do this one, all right? So we're going from this. So if we treat this as 1 move, 2 moves, 3, 4 moves. So 4 total. Divided by, what are your repeats? 2 factorial, which is just 2. So this one gives you 35. This one gives you 6. So how many ways can you go from A to B? 35 times 6, which is 210. So if they're nice rectangles, that's the easiest way to do it. Even if it's three-dimensional, you can do the same thing.
If it's a tesseract.
Actually, that's right.
Okay. We're going from A to B. So we can go 1, 2, 3. Oh my gosh. 3, 4, 5, 6 moves. What are the repeats? 2 and 3. 3 across and 2 down. That'll give you 60. 60 ways to go from A to B. Okay? So if there's no weird shapes or anything in the middle, it's easier to use this. And if they're connected at a corner, it's easier to use this and you just multiply the answers. But of course, I'm not going to give you ones like that. I'm going to give you ones like this. So, this is not a nice shape. It's not connected at a corner, so you have to use Pascal's triangle. Okay? So we're going from the train station to the football stadium. Put a 1 there. Always start with 1s. Every intersection, you put 1s until you basically had to turn a corner. So you stop here. So then these are going to be 1s all the way down. That's the outside of Pascal's triangle. Yep. You can try. Go for it. You can try.
It probably would take longer, but you could do that, right?
Yeah, but it's going to be hard. All right, this method is actually fairly straightforward. Okay, and then we just fill in everything. So these numbers here are always connected. So it's 2, 3, 4. What's this number on the outside here?
6.
Add the numbers it's connected to. Is there anything up?
No.
Is there anything left? 4. So it's 4. If it's 4 ways to get here, how many ways to get here? It's just 4, because there's no other route you can take to get there. Okay. Then you go to the next row. 2 and 1 is 3. Whoa. 3 and 3 is 6. 6 and 4 is 10. 10 and 4 is 14. And then you go down again. 4, 10, 20, 34. Then you go to the next row. 4 and 1 is 5. 15, 35, 69.
Hey.
That was Marco for all the immature people out there. What's this one right here?
40.
Nope. 15. You're always adding up and left, right? So that is 15. Oh my gosh.
That's 15.
It was. There we go. That doesn't look like 15 either. There we go. Okay. And then the next one is 50. And the final one is 119. There's 119 ways to get from the train station to the football stadium if you can only move to the right and down. And this is Pascal's triangle. Turned on its side, the rows look like this.
And my question is, how is this practical?
I don't know.
Like,
Well, basically it's just teaching you can overlay Pascal's triangle into grids and stuff like this. Whether you're going to use that or not, I have no idea. The what? The hypotenuse?
ignore the grid. Which is when you can go through the right way.
Hey, it's just a puzzle. All right, we're going from the train station to the football stadium.
Are we not allowed to go into the city? But
Can't go through the city park. It's off limits to everybody. All right. So one there. One.
that's not. There you
All right. All the numbers in the center. 2, 3, 6, 7. Go to the next row. 3, 6, 10, 21, 28. Kind of stop there because you can't go into the park. What is this number here? On the other. What's number here?
21.
It says 21 because you look, we're always adding up and right. So here up is 21. There's nothing there. You can't come through the park. Yeah. So this is going to be 21. The next one's going to be 49. Go to the next row. 4 and 1, 5. 15. 35. What's this number right here? 35, right? And then this one is 56. And then the final row, '80 and 1191.
147. 252.
So just in case you needed to know, if you were on a grid with a park in the center and you could only move towards the football stadium without going through the city park, there's 252 ways to do that.
Actually, does the placement of the park affect?
It shouldn't.
Yeah, it should.
Can we try that?
You draw another grid and try it. I'm not going to draw it, you can.
We can do it as a class. To help show.
We can. You want to?
I think it would be helpful.
Okay, well, let me stop the video. Let's do one more and then we'll do it at the end. Last question.
Oh.
How many ways can a pinball fall from the top to the bottom?
A lot.
All right. 1. What goes down the sides? 1, 1, 1, 1. What number in here? Boo. 3. 3. This one is actually exactly like Pascal's triangle. And that is different. So 1 and 4, 5. 4 and 6 is 10. 10, 5. 15, 20, 50, 6. 35, 35, 21, 70, 56,
Okay, but this is like a more accurate grade of what Pascal's triangle actually is.
because it's lines up a little more. 126 ways to go from top to bottom. That's like Plinko. You ever seen Plinko and Price is Right? Does anybody watch Price is Right?
I have.
Have you seen Plinko? Who hosts that show now? It's you do?
I haven't watched it.
You were a kid?
Yeah.
I haven't watched it in a long time
It's
either.
on at like 9 o'clock in the morning.
I know. It's like, who's watching this?
Yeah. It's either old people or.
People who don't have jobs?
Yeah.
No. The Baldwins? I'm young. All right. Do all the questions that ask you to do that. Bye, people. Have fun at prom tonight. Or if you're watching this after prom, hope you had fun.